Hi all, and thanks for joining. Today I'm going to walk you through this tactics, very easy Windows room available on Hack the Box platform. This is the 10th and last box from this Starting Point series of very easy machines, and it's tier 1. You need to walk before you can run. This machine is tagged with protocols, SMB, Reconnaissance, and Misconfiguration, so you have an idea what to expect to see and learn from this box. I already downloaded this official write-up, and I will follow along it, mostly focusing on hands-on part, and towards the end of the video, I'll go through these questions. Now let's connect to Hack the Box Starting Point VPN network, and then spawn the target instance. Here is my IP address in the upper right corner on the Hack the Box network. In a couple of moments, this Hack the Box right side panel should update. There it is. Great, let's proceed to spawn the target instance. And let's read through the walkthrough until we get back the IP address of the target instance here. So in this room, we'll be taking a look at a misconfigured SMB share, which offers two types of attack vectors. One is discoverable and easy to employ. The other involves the installation and deployment of a popular exploitation framework, and while dearly effective, it comes with its own disadvantages in terms of discoverability. In the wild, you will always be met with such choices. Taking the right step, knowing the right path, and perceiving the consequences of your attack vectors will prove vital to your career. And let's go through this enumeration section also. In order to get a general view of the target host, we will begin with an always popular Nmap scan. However, we'll be using a new switch for the scan. Instead of the -SV service detection switch, we'll be using -PN, that's with big P, small n. On a real-world environment, you should expect firewalls to be present, intercepting connection at every step and denying all non-standard connection requests or scan attempts. During a typical Nmap scan, the Nmap script will perform a form of complex ping scan, which most firewalls are set to deny automatically without question. Repeated denials will raise suspicion, and during a typical scan, a lot of the same requests will get denied. The -PN flag will skip the host discovery phase and move on straight to other probe types, silencing your active scanning to a degree. However small, this degree might prove to be the lifeline you needed before you even considered actively attacking the host. So I'll first run the ping command just to see its output in this case, and proceed to run this sudo nmap -sc-pn then target IP command. So we see here Windows machine replying to ping with TTL 127. And let's proceed to run this nmap command. We expect to see 135, 139, 445 ports open from the 1000 TCP ports scanned with this command. From the walkthrough, according to the results of the nmap scan, the machine is running the Windows and the server message block service on port 445. Let's see in the TCP and UDP port cheat sheet, strictly looking at screenshot from the walkthrough, 135, 139, and 445. PC, 139 NetBIOS, and 445 SMB. Let's save this nmap output to a notes file. And let's proceed first by focusing on SMB. And we will interact with this file sharing protocol using SMB client command line tool. I'll check if it's already available on my attacker machine. If not, I'll proceed to run this installation command. It's all pre-installed. Let's run the SMB client -h to see its switches and options. Upon exploring the choices, we will settle on the command below in order to list the various available shares -big L and to attempt a login as the administrator account, which is the high privilege standard account for Windows operating systems. Typically, the SMB server will request a password, but since we want to cover all aspects of possible misconfigurations, we can attempt a passwordless login. Simply hitting the Enter key when prompted for the administrator password will send a blank input to the server. Whether it accepts it or not, we still need to discover. So let's do that. Let's run SMB client -big L, then target IP. Then -big U and administrator. Okay, we now see 3 administrative shares: admin, C, and IPC. And from here, we have 2 options of attack. One is loud, one is not. First, SMB client simple navigation to C share with administrator authorization. And second option, PS exec py from impacket involving impacket installation and common attack surface, big fingerprinting. So let's first try with option A, SMB unprotected C share. First step, let's try to connect to admin share. Using command SMB client, 4 backslashes, then IP address, the target instance, then 2 backslashes, then share's name, then -big U administrator, just enter here. Let's type help to see what commands we have available. Though for the sake of time, let's switch to C share. Enter again. Let's type dir here. So we have access to the file system. From here, we will directly navigate to the standard root flag location on any hack the box vulnerable machine. And again, for the sake of time, To find the flag, we'll switch immediately to C Users Administrator Desktop. And let's download the flag using the get command. And let's exit from here. Now to answer last task question, we would run cat flag.txt and provide the characters of the flag.txt file. So that's first approach. Second approach, option B, is inpacket. And let's try out second option. We managed to get the SMB command line interactive interface. However, since we can access this administrative share, we will try to use a tool called psexec.py to exploit this misconfiguration and get the interactive system shell. The psexec.py is part of the inpacket framework. Inpacket is a framework written in Python for working with network protocols. It is focused on providing low-level programmatic access to the packets, and for some protocols, e.g. SMB and MSRPC, the protocol implementation itself. In short, inpacket contains dozens of amazing tools for interacting with Windows systems and applications, many of which are ideal for attacking Windows and Active Directory. Inpacket creates a remote service by uploading a randomly named executable on the admin share on the remote system and then register it as a Windows service. This will result in having an interactive shell available on the remote Windows system via TCP port 445. psexec requires credentials for a user with local administrator privileges or higher, since writing to the admin share is required. Once you successfully authenticate, it will drop you into an anti-authority system shell. And you can download the inpacket from this link in case it's not already available on your attacker instance. And the psexec utility can be found at inpacket examples psexec.py. And let's check that on our system. I'll switch to a new terminal. And let's locate inpacket. Let's try first with the locate, then where is inpacket. Let's get first 10 results. Opt inpacket, and let's see with where is. Okay, shows another location. Let's try first from opt inpacket. Let's clear the screen first for better visibility. Let's switch to opt inpacket. Then according to the instruction, there should be examples subdirectory, then psexec.py will be there. Let's try with autocomplete. It works, and yes, this is directory. Okay, let's stop here and let's run ls-l ps and autocomplete. It works, it's there, great. And let's try to run this command from the walkthrough psexec.py-h. Let's just run psexec.py without -h. let's type it as /psexec.py, then -h. That worked. And then let's use this syntax: psexec py administrator at target IP address. During option 1, we did not use credentials for administrator access, so we'll just type enter here also. Just enter here. It found writable share admin. Uploading file. Starting service. And we have a shell. Now let's type who am I. Great. Anti-authority system, and as in option 1, let's switch to see users administrator desktop to see the flag. And we can type the flag from here. Great, so with that we completed the hands-on part, and we can switch to the box user interface to answer the task questions. Task number 1: which nmap switch can we use to enumerate machines when our ping ICMP packets are blocked by the Windows firewall? So that's the switch we used. Task 2: what does the 3-tier acronym SMB stand for? In case it wasn't mentioned in the walkthrough, you can find the refresher in the TCP and UDP port cheat sheet. Task 3: what port does SMB use to operate at? We saw that in the nmap output. Task 4: what command line argument do you give to SMB client to list available shares? That was -big L. Task 5: what character at the end of a share name indicates it's an administrative share? We saw 3 shares available, and all of them had appended $. Task 6: which administrative share is accessible on the box that allows users to view the whole file system? That was C administrative share. And just to mention, here are, for example, a couple of pages where you can check out more on IPC share. Task 7: what command can we use to download the files we find on the SMB share? So we use get. Task 8: which tool that is part of the in-packet collection can be used to get an interactive shell on the system? We used psexec.py. And after submitting root flag characters here, we can say we open the box. And if needed, stop the target instance. That would be all for this video. Like and subscribe if you enjoyed this one. Until next video, bye for now.